Good morning, children. Here I am again with the chapter Chemical Bonding. In the last class, we have discussed about different types of covalent bond, isn't it? Single covalent bond, double covalent bond, and triple covalent bond. I think all my students have practiced it, how to draw the sharing of electrons between itself. Today, I am here again with another new property that is known as electronegativity. Okay, I hope you haven't heard about this term, electronegativity. Actually, this electronegativity was a term. Actually, it is a term that can be used along with ionic bond and covalent bond. Electronegativity was discovered by, or that property was put forward by an American scientist, Linus Pauling. Okay, Linus Pauling. Now, I will tell you what is electronegativity. See here, in ionic bond, the bond was formed by sharing, not sharing, that is gaining or losing of electrons, isn't it? Some element will be donating the electron and some will be gaining that electron. What about in covalent bond? The electrons inside the elements, they are sharing the electrons between them, isn't it? Between two fluorine atom, between two chlorine atom, then oxygen atom, nitrogen atom, isn't it? So their sharing is taking place. So anyway, this shared electrons will be having a, they will try to keep that electrons towards itself, isn't it? So that is a term that is known as electronegativity. Electronegativity means the tendency of each atom to attract the bonded pairs of electrons towards itself. So if you have a toy, if you got a beautiful toy with you, what will you do? You will try to keep it with you without losing it, without making it dirty, isn't it? Nothing should happen to that. You will take care of that doll or whatever gift you have got, like that. So in the case of these elements, these bonded electrons or bonded pairs of electrons are really a gift to them to keep them stable. So what will they do? They will have the ability to keep that bonded pair of electrons, to attract that bonded pairs of electrons towards itself. This property is known as electronegativity. Now, this Linus Pauling, he put forward, or he found out the electronegativity of different elements, and by that way he has put forward a Pauling scale or electronegativity scale. And what is the use of this? Using this electronegativity values, just knowing those electronegativity values, you will be able to identify whether the given bond or this given element or given compound will be having a ionic bond or a covalent bond. Okay, we will look into it. So here you can see the names of some compounds. Now we are going to find out the difference in the electronegativity value. So from the text in your textbook figure 2.10, the electronegativity values are given, which was found out by Pauling. Okay, so first the compound is carbon monoxide. So carbon and oxygen will be there. So we will be finding out the electronegativity value of carbon and oxygen. Okay. So the electronegativity value of carbon is 3.44 and about oxygen is 2.55. Okay. So what will you do? You have to take the difference between these two. So when you are taking the difference between these two, you will be getting it as 0.89. Okay, 0.89. Now next is sodium chloride. So from the table I can find out that about sodium it is 0.93 and chlorine is 3.16. Okay, so 3.16. So we won't be able to subtract it like this. So what will we do? We will be subtracting it a greater number from a smaller number. That we will be doing. So the answer is about 2.23 something. Okay, the answer will be 2.23. Next is methane. Methane means CH4. Carbon and hydrogen. Carbon we know it is 3.44 and what about hydrogen? 2.20. Okay, so you will be getting 1.24. Is it like that? 2. Okay. No, it's not like that. Its carbon is 2.55 actually. 2.55 and hydrogen is 2.20. So you will be getting 0.35. Yeah, 0.35. That's right. 0.35. And what about magnesium chloride? Magnesium is 1.31. So we can write it here directly. And about chlorine is 3.16. Okay, 3.16. 3.16 minus 1.31. So it will be 5 here, 8 here and 1.85. Then what about sodium? Sodium is 0.93, right? And what about oxygen? Oxide means it's oxygen. So 3.44. 3.44 minus 0.93. You will be getting it as 2.51. So you have got this much values. Okay. Here you have got 0.89, 2.23, 0.35, 1.15 and 2.51. So how can you identify the nature of the compound using this difference in the electronegativity value? So when Pauling found out these electronegativity values, he found that if the difference between the electronegativity values, if the difference between the electronegativity value is less than 1.7, okay, if it is less than 1.7, okay, less than 1.7 or greater than 1.7. We have set up the nature of the compound using these two properties. That is, if you have found out the electronegativity value and you have found that the electronegativity value is less than 1.7, then it is having covalent character. So we can find out how many of them are bonding using covalent. See, here it is 0.85, 0.89. It is less than 1.7. So it will be covalent. Okay, here also 0.35 less than 1.7, covalent. Then which one? Only that one. Now, what about more than 1.7? So if it is less than 1.7 is covalent, then we should know what is the other thing that is greater than 1.7. So greater than 1.7 will be ionic. Okay, it is ionic. So this way, the Pauling electronegativity scale. Okay, so for your exam, the electronegativity values will be given. What you have to do is just find out the difference between them and find out whether it is less than 1.7 or greater than 1.7. If it is less than 1.7, it is covalent character, and if it is greater than 1.7, it is ionic character. So again we are going to study about a new concept, that is polar nature. Okay, so I'm going to write H2, Cl2, O2, N2. Then HCl, CH4, CCl4. Okay. So I have written H2, Cl2, O2 and N2. Then HCl, CH4 and CCl4. Now if I am asking you, do you find any similarity in these compounds? You will be saying yes, because we have studied these compounds, how they are bonding through covalent nature, isn't it? Now there is another one difference between them, isn't it? See here, H2, Cl2, O2 and N2. Here The bonding is taking place between the similar elements, isn't it? The bonding is taking place between two hydrogen atom, two chlorine atom, then two oxygen atom and two nitrogen atom, isn't it? The bonding is taking place between similar elements. Because of that we can call them as homodiatomic molecule. Homodiatomic molecule. So what do you mean by the term homo? Homo means similar, same. Di means two atoms. So similar atoms, similar elements, they are having two atoms. And what about this one? Here you can see hydrogen and chlorine, two different elements. Carbon and hydrogen, two different elements. Carbon and chlorine, extremely two different elements. So I am going to talk about these type of different elements. Okay, so when the bonding is taking place between chlorine, okay, similar elements, the shared electron, okay, the shared electron is taking place equally, or the electron is shared equally because they are similar, isn't it? Now, for example, I am taking hydrogen and chlorine. Okay, hydrogen and chlorine. I am talking about the bonding that is taking place between hydrogen and chlorine. We have studied their bonding, why they are sharing their electron through covalent bonding, isn't it? They have covalent character. Now, as we have studied, this chlorine atom, okay, this chlorine atom is having a higher electronegativity value than hydrogen, isn't it? By looking into the Pauling electronegativity scale, you can find out that chlorine is having a higher electronegativity value than hydrogen. So from that itself, you can understand that chlorine is more electronegative than hydrogen, isn't it? So the one person which is having a higher electronegativity value, what that element will do? That element will attract that electron towards itself. They will be giving a more attractive force or attractive force to keep that shared pair of electrons towards itself than hydrogen, because hydrogen is having a lesser electronegativity value. Okay, so the one person which is having a higher electronegativity value, I'll tell you one thing. You are seeing a film. Okay. One person is very lean, okay, very lean, and the other person is such a muscle man, okay. So those two are fighting. So this lean person who is fighting, will he able to defeat that other man who is a stronger person, stronger muscular person? No, because that person is more stronger, and he will be trying to defeat that lean man very easily, isn't it? In the same way, the chlorine which is having a more electronegativity value will attract that shared pair of more towards itself. And because of that, that pull, that attractive pull, or to attract that electron bonded pair towards itself, this chlorine will be getting a delta negative charge, and the hydrogen will be getting a delta positive charge. This is called the partial positive charge. Okay, partial positive charge and partial negative charge. Okay, this is this letter is known as delta. You will be terming it as delta. So the one person who is attracting the bonded pair towards itself with more force towards itself, he will be getting the partial negative charge, and the other person will be getting the partial positive charge. Okay, so this can happen in other covalent compounds also. So this a familiar polar molecule is also there, that is known as our water. Water is an example of a polar molecule. Okay, and because of these properties, actually the difference in the nature of this chemical bonding, it also reflecting in the physical and chemical properties of some compounds. See the properties ionic compound and covalent compound. Okay, Now, ionic compound, solid. It is solid state. Solubility in water. Ionic compounds are generally soluble in water. What about its electrical conductivity? Conducts electricity in aqueous and molten state. Melting point and boiling point is very high. What about in covalent compounds? Covalent compound, these can exist in solid, liquid or gaseous form. Then solubility, generally they are insoluble in water, but they will be soluble in organic solvents like kerosene, benzene, etc. Then electrical conductivity, not a good conductor of electricity. Then what about the melting point and boiling point? Usually very low. Okay, so we have come to the last portion of the chapter, that is valency. You have heard about the term valency, isn't it? Valency is known as the combining capacity of an element. Or I can say that when an element is taking part in bonding, okay, whether it is ionic bonding or covalent bonding, there will be some number of electrons that will be gained, that will be lost, or that will be shared, isn't it? There will be some elements which are donating a few electrons. There will be some elements which are gaining those electrons, and sometimes no gaining or losing, only sharing. Okay, so that will be accounting the valency of that element. Okay, now for example, in sodium chloride, NaC, isn't it? Sodium, as you know, it is having atomic number 11. Electronic configuration 2, 8 and 1. And what about chlorine? 17. 2, 8, 7. Now since we have learned about ionic bonding, it will be easy for you to tell me that how many number of electrons are being donated by sodium? Yes, 1. And what is the number of electron that is gained by chlorine? 1. Okay. Lost and gained. Okay. This is the number of electrons that is lost. So, 1 electron is being lost by sodium and that 1 electron is being gained by chlorine. So, what is the valency of sodium? Yes, 1. And what is the valency of chlorine? 1. Okay, in magnesium fluoride, the atomic number of magnesium is 12. Electronic configuration 2, 8, 2. Then fluorine 9, 2 and 7. So from the electronic configuration, you can easily tell me how many number of electrons is being lost by magnesium? Yes, 2. Now, what about fluorine? 1 electron, isn't it? Only 1 electron is needed. But since it is F2, you can understand that there is one more fluorine, isn't it? 2, 7. So, here it needs 1 electron, here it needs 1 electron. So, the valency of fluorine is 1. That's why the formula I will tell you about later. Anyway, the valency is 1. It is a valency of fluorine is 1 and about magnesium is 2. So, what is the need that we should understand these things? We understand read about electronic configuration. We drew the Bohr atom model. Now we have come across this ionic bonding, covalent bonding, everything. And now the valency. What is the need of this valency? See, when you are writing if I are telling you water, you are easily telling me the formula is H2O. I am telling you carbon dioxide, you will write CO2, isn't it? Because we are able to represent it using chemical formulae. We have studied in 8th standard how to draw that, how we are writing that chemical formula. We studied about it. Now we are going to introduce this valency into that chemical formula. Chemical formula is very useful for us because we are able to represent the names of some elements that is very common to us using symbols. Okay, so here we are going from valency to chemical formula. Okay, now I am going to show you about that. So here, I'll give you an example. hydrogen fluoride. Okay, I'm just writing the name hydrogen fluoride. Okay, so what you have to do is that first you will write hydrogen here. Hydrogen is having only one electron, so no worries. Fluorine 2 and 7, isn't it? So you know that hydrogen is in short of one electron. Here fluorine is also in short of one electron. Now what you have to do is that you write hydrogen here and you write fluorine here. Okay. Now what you have to do is that you write the valency of each element on top of it. Okay. Now what is the valency of hydrogen? 1. What about fluorine? Fluorine needs one more electron to get the octet state, to get the stable state. So here also the valency is 1. Now what you are going to do is that cross multiply it. You multiply fluorine into 1 and hydrogen into 1. What will you get? Hydrogen fluoride. Here is the formula. Okay. Now there are different examples. Now magnesium chloride. Magnesium chloride. First what you have to do? Write magnesium. Atomic number 12. 282. Chlorine. Atomic number 17. 287. Next what you have to do is that you have to write magnesium here. Then chlorine next to it. Then write the valency. Find out the valency. What is the valency of magnesium? How many number of electrons will be lost by magnesium? Yes, 2. Yes, write 2 here. Now, what is the valency of chlorine? Chlorine already have 7 electrons. It needs one more electron to attain the stable state. So, what is the valency? 1. Now, cross multiply. Chlorine, magnesium into 1. Magnesium. Chlorine into 2. Cl2. This is the formula of magnesium chloride. Now, another example. Carbon tetrachloride. Carbon tetrachloride. Okay. Carbon. Atomic number 6. 2, 4. Chlorine. Similar. 2, 8, 7. Okay. So what you will do? You will write chlorine here. And chlorine and carbon. Okay. Then what you will do? Since carbon is having only 4 electrons in the outermost shell, you know that it needs 4 more electrons to attain the octet state, or it should share. Anyway, he can't donate all those electrons, or he can't receive any 4 electrons. So what he will do? He will be sharing the 4 electrons with some person. Okay, so you can write 4 here. What about chlorine? 1. Now cross multiply. Carbon into 1. Carbon. Chlorine into 4. Cl4. Carbon tetrachloride. Now, next is carbon dioxide. Carbon dioxide. Okay. So in carbon dioxide, carbon, I am writing 6, 2, 4, oxygen, atomic number 8, 2 and 6, isn't it? Now I am going to write the valency. Okay. Now I can write carbon here, oxygen here. Carbon valency is 4 because it will be sharing the 4 electrons. Now what about oxygen? Oxygen already has 6 electrons in the outermost shell and it needs only 2 more electrons. So the valency is 2. Yes. Now you are cross multiplying it. Okay. When you are cross multiplying it, C into 2, C2. O into 4, O4. Okay. Now, in cases like this, that is, here C2O4. Have you heard about such a formula for carbon dioxide? No, isn't it? Then why the C2O4? Now, what we have to do in these cases is that if these two elements, if these two numbers, they are equally divided by a single number, that is equally divided by these numbers, what we have to do is that this 2 and 4 is divisible by 2, isn't it? So what we will do is that 2 divided by 2 and oxygen 4 divided by 2. So what will you get? CO2. That is 2 divided by 2 is 1. 4 divided by 2 is 2. So you will be getting carbon dioxide, isn't it? So this is the way how we are getting the formula for carbon dioxide. So thus we have come to the end of the chapter chemical bonding. Hope all my students have understood this chapter very well. Thank you.